Alright, hi everyone, welcome to my YouTube channel City of Elections. So in this video we'll be talking about Picard's method. So of course it's another method to get a numerical solution, okay, of differential equation or a mathematical model. Now, Picard's method. But first, in our last video we talked about Euler's method, okay? So, and I said we should just complete the table. So I have the complete table here to show to us, okay? It is a complete table. Alright, so of course this same thing, this part here is dy, this part here, this column is for dy dx. So of course you can watch the video to see how we got this first part. So we did this row and this other row in the last video, and I said the rest we can just work that ourselves by going with this, with what happened here. So if you do this for this row, this is the answer you get, and if you do this for this row, this is the answer you get. So we just repeat that until we get to when x is 2 and value for y. That's it. Okay. All right. So now in this video we're talking about Picard's method. So for Picard's method, we consider the differential equation. Okay, this is a first order differential equation. Okay, so considering this first order differential equation, taking it as equation 1, we integrate according to what we have here. Okay, say for y0, y equals y0, for x equals x0. So if we integrate equation 1 between the limits x0 and x, this is what we'll have. Equation 1 is this now, dy dx equals f y comma x. So if you integrate this, from y0 to y, from x0 to x. Doing this will result in, of course, this x term, we move it this way. Okay, so we just have y here and we just have x here. So this will result, we can simplify to have this dy equals, okay, dx. Good. Write your x well. Thank you. Now, of course, differentiating this will give us y minus y0. Let me put it this way. Okay. I guess I just skipped something, but I hope you okay. Let me address that. So this differentiating dy will give us y. Okay, and that is y from y0 to y. So now I'm not going to differentiate, integrating. Why does it differentiate? Please, integrating dy will give us y. Okay, so now I will not integrate this part because this has an x term and you also have a y term, so I will not integrate that part. I'll leave it like that. So this will result in y minus y0 equals this. Okay, now good. Now of course if you bring this guy this way, we are going to have, I think I should just copy everything. We are going to have this. So this guy will move over to this side and become, this one out, become y0 plus all that. Good. And here will be x. So this is the Picard's formula, or what we use for Picard's method, question 2. Okay, now This is for y, and I said we did not differentiate this, we did not integrate this part because we have a y term here. So if we substitute y0 for y in this part, okay, we substitute y0 for y, we are going to get the first approximation. So to get our first approximation for y, so y1, this will be y0 plus everything we have here, x, then this part here will be what? y0 dx. Okay, we can call this equation 3. Now this is the first approximation. So if we need our second approximation, if we need the second approximation, I'll copy this whole thing. If we need the second approximation, this is what will happen. Same thing, but since we are looking for second approximation, look at what will happen here. Watch your screen. Second approximation, right? That means here will be what? 1. Bam. Okay, can you spot the difference? When we're looking for y1, that's the first approximation, we are going to replace y, which is this y, with y0. When we are looking for the second approximation, we are going to replace y0 with y1. So it's just like this guy step up once, this guy step up once. If we are looking for third approximation, here we want y2. The rest things remain the same. Okay, so this is just the idea for Picard's method. So yeah, this is just the idea. Now in case, of course, you can pause the video, slow down, check again to see the whole stuff so that you understand it. Okay, now in our next video we are going to work an example using the Picard's method. So all we did in this video is just consider a first order differential equation, and then from there we just integrate both sides, but we integrated only the right hand side, of course taking the x this way, and we did not integrate the left hand. We integrated the left hand side but we did not integrate the right hand side because of this y term here. And we said when looking for first approximation, you just turn this y term here to y0. For second approximation, here will be y1. Of course, y2 means second approximation. Okay, so that's just all for this video. Comment, like, share, subscribe, and I'll see you in the next video. Thanks for watching. Bye.